All right, we're going to take a look at the Earth-Sun relationship. So I want to show you how you find this here. If you go to Edmodo, and then the blend space for weather chapter 3, and there's some great videos here. I really like this one with Neil deGrasse Tyson, very intelligent guy that explains things so well. But we're today going to look at the Earth-Sun relationship. So here's a little interactive website here. Okay, so we're learning about how the Earth's movements through space cause the seasons and cause climate and temperature to change, climate and weather to change. So let's just talk about this. The Earth here. The Earth is in orbit around the Sun, so that's this dotted line is the Earth's orbit. We also say the Earth revolves around the Sun, or one full orbit is, we call that a revolution. Okay, so the Earth it revolves around the Sun, or it goes in revolution around the Sun. Okay, the Earth is also on its axis, so you can see that the axis is here. They always draw like this straight line going through the Earth. Now, I always want to say this, there's not actually a pole at the top and bottom of the Earth. It's just that the Earth spins around a certain point, so to help us visualize it in our heads, we always draw that little line there. Okay, but there is no real line there at the North Pole. So the Earth rotates around its axis. It goes actually really fast because it has to rotate one full turn in 24 hours. So it goes pretty fast, and it rotates counterclockwise, just like it is here in the picture. All right. The other thing about the Earth on its axis is it's tilted on its axis, and that's really important because that is the reason we have seasons. Okay. So right now, if you look here, it says Earth at the March equinox. So the March equinox is March 21st or 22nd, and that's the first day of spring. First day of spring is the March equinox. Okay, or spring in the northern hemisphere, I should say. It's the first day of fall in the southern hemisphere. All right, now down here, we can see the Earth going through the 12 months. So it's starting in March on this timeline, and it'll end back at the March equinox. Okay. So we'll let it go, and then there's the Earth. It's rotating, but it's also revolving. So it's spinning, 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 but it's also revolving. And then it's going to stop here, I think. There, the Earth at the June solstice. So that's going from the first day of spring, March equinox, and it revolves to the first day of summer. The June solstice is the first day of summer. And you can see how the Earth is tilted on its axis. The northern hemisphere is leaning towards the sun, so that means that the northern hemisphere is getting more direct sunlight, and so the northern hemisphere heats up, and that's why we have summer starting on the June solstice. June solstice is because the northern hemisphere is tilted towards the sun. Now down here in the southern hemisphere, they have winter because they're tilted away from the sun. The other thing I want to point out is this side here that's bright, that's daytime, and this side here is nighttime. So the Earth is still rotating, still going through day and night, but even over here when it's nighttime, it's still a little bit warmer because it's like a warm summer night because the northern hemisphere is tilted towards the sun. Okay. All right, let's continue to the fall equinox. So there is the Earth rotating and revolving around the sun. And when it gets to September 21st, we call that the September equinox. Okay, so now, kind of like when it was the March equinox, this is the first day of fall, and the Earth it's not leaning towards the sun or leaning away from the sun, so it's getting equal sunlight on the north and the south. And it's gradually getting a little bit colder than it would in the summertime. All right, let's continue. And now it's getting into October, November, December, and then December 21st is the winter solstice, or the December solstice. So now you see that the northern hemisphere is tilted away from the sun, so there's less direct light hitting the northern hemisphere. And so gets cold here in the northern hemisphere. Now down here in the southern hemisphere, it's tilted towards the sun, so the southern hemisphere is getting warmer. Okay. Again, you have daytime and nighttime. So this would be like a cold winter day, and over here is a cold winter night. Notice that the North Pole now is completely in darkness. It never enters into the daylight. So the North Pole, and even parts of northern Canada, northern Alaska, they'll have 24 hours of nighttime for a week or two during the winter months, because they never are tilted close enough that they're getting any daylight. Wouldn't that be strange? All right, let's continue. And now the Earth is revolving, and it'll stop at the March equinox again. And you can see how neither side is tilted towards the sun. So the northern hemisphere and the southern hemisphere are kind of getting the same equal amounts of direct sunlight. And so both sides are equal temperatures. The northern part and the southern part is equal temperatures. The last thing I'll say is the equator. If you watch this again, I think I can speed it up. No? Oh, you just inching it through. Okay. The equator, this black line here, is always getting direct sunlight. So no matter where it's at, it's always getting direct sunlight. So that's why the equator is always warm. And the same thing with the poles, they're always getting indirect sunlight, so that poles are always cold. No matter what time of year, the poles are always cold and the equator is always warm. And then the in-between areas, the temperate zones, we call them, between that red and the green there, the temperate zones are always changing. That we have cold winters, we have warm summers, we have fall, we have spring, so we have 4 different seasons. Okay, I want to see what this does. Oh, okay, that's useful too. Yeah, this kind of shows the tilt, how the northern hemisphere is getting lots of direct sunlight because it's tilted towards the sun. Holy moly, all kinds of info here. And then as it gets into fall, the northern hemisphere isn't so much tilted anymore. And so the northern and southern hemispheres are both getting equal light. And then as it gets into winter, the northern hemisphere is tilted away from the sun. And so there's very little direct light getting to the northern hemisphere. It gets really cold. And then it gets back into the springtime, where the northern and southern hemisphere are getting kind of equal amounts of light. Okay, I think this is a really useful interact. It helps me visualize all the different movements. Play with it for a while. Talk yourself through all the different seasons. It's worthwhile to know for sure.